Have you ever really stopped to think about how nature powers itself? I mean, really think about it? It's completely different from how we power our world. And that difference, well, it holds some massive clues for building a more sustainable future. We're going to dive right into this tale of two systems, nature's way versus our way.
Just check this out. It's like looking at two totally different engines. On one side, you've got a forest. It just hums along quietly, powered by sunlight. It's been doing this for millennia, creating these incredible, complex systems without any waste at all. Then you've got a city. It's loud, it runs on fossil fuels, it creates a ton of pollution, and let's be honest, it's constantly worried about the fuel running out. Two engines, both using energy, but they couldn't be more different.
So it really makes you wonder, doesn't it? What on earth can this quiet, super efficient, natural engine teach our big, noisy, powerful one about sticking around for the long haul? That's exactly what we're going to get into.
Right, let's start by digging into nature's sustainable blueprint. We're basically going to uncover the three golden rules that have kept life ticking along on this planet for, well, for billions of years.
Okay, principle number one. It's so simple, you might almost miss how important it is. Nature runs on renewable energy. And where does pretty much all of that energy come from? Yep, the sun.
And solar power is everything. We're not just talking about plants growing. The sun's energy is the engine behind the water cycle. It's what pushes carbon and nitrogen around. It's what creates winds and even those massive ocean currents. You can think of it like a constant, reliable solar paycheck coming in every day. And that's what makes the whole system truly sustainable in the long run.
All right, let's move on to the second principle. Now, this one sounds a bit more techy, but trust me, it's a massive deal. It's this. Nature uses resources with a low energy density. So, what do we actually mean by energy density? It's just how much energy is crammed into a certain amount of stuff. A really simple way to think about it is comparing a log for a fire with a liter of petrol. The petrol is packed with way more energy, so it has a much higher energy density. And sunlight? Well, it's really spread out by the time it gets to us, making it a perfect example of a low energy density source. And here's the genius part. Nature is totally fine with that. It doesn't need some super concentrated fuel source. It's evolved to capture this spread out solar energy just as it is. It's like nature sips its energy from all over the place instead of gulping it down from one spot.
Okay, the third and final principle in nature's rulebook is all about temperature. And honestly, it's pretty amazing. Unlike us, nature pulls off the most ridiculously complex chemistry without cranking up the heat. It literally keeps its cool. I mean, just think about it for a second. Photosynthesis, making sugars from sunlight, happening at whatever the outside temperature is. The enzymes in your own body are making stuff happen at a comfortable 37 degrees Celsius. And then you've got these incredible bacteria in the soil, just casually pulling nitrogen out of thin air. No furnace, no blast of heat needed. It's amazing.
Okay, so that's nature's way. Now let's hold up a mirror and take a hard look at our own approach. And you're about to see that our high-energy habit is pretty much the complete opposite of everything we've just talked about. And this is probably the biggest difference of all. Remember how nature lives off that steady, renewable solar income? Well, we do the exact opposite. Our systems are built on burning through a finite, non-renewable fossil fuel capital. It's like we found a giant savings account that took millions of years to fill, and we're just spending it as fast as we can, knowing full well it's never going to be topped up.
And that whole energy density thing, yeah, we do the polar opposite there too. Our entire industrial world is designed to use high energy density fuels, coal, oil, gas, you name it. And why do we do that? It's simple, really. We need to generate crazy high temperatures for all our industrial processes, and you can only really do that with concentrated fuels.
But honestly, the most jaw-dropping contrast, the one that ties all three of these principles together, is temperature. And there's no better way to see this than by looking at how we get nitrogen for our crops. So here it is, the nitrogen fixation showdown. In one corner, you've got nature, bacteria in the soil just doing their thing at normal temperatures and pressures. It's clean, it's sustainable, it's just part of the cycle. And in the other corner, us, the Haber process. To do the exact same job, we have to use brutal temperatures and pressures, we need an iron catalyst, and it just devours massive amounts of fossil fuel energy. It perfectly sums up our whole brute force approach.
Whew. Okay, so we've seen the two systems side by side, and it's quite a contrast. So the big question is, now what? How do we take what we've learned and start applying nature's blueprint to build a future that actually lasts? Let's put it bluntly. How can copying what nature does with energy actually help us become sustainable? What does that look like in the real world? Well, it all boils down to something you'll be very familiar with: reevaluating our carbon footprint. Our entire model, using high-density fuels, burning them at high temperatures, that's what creates our huge carbon footprint. So if we want to shrink it, following nature's lead is the most direct way to do it. So what are the lessons? What's the game plan? Well, first, we've got to properly shift from non-renewables to renewables: solar, wind, the whole lot. Second, we need to get clever and design technology that can actually use those low energy density sources. And third, and this is maybe the most exciting bit, we need to develop low temperature ways of doing things, using things like enzymes and bacteria to do the hard work for us, just like they do in the soil. And here it is, all laid out. This table is a perfect summary of everything we've talked about. Look at the divide: nature, renewable, low density, low temp. Us, non-renewable, high density, high temp. When you see it like this, you can really see the problem, but you can also see the solution, can't you? This quote, right from the AQA spec, really nails it. The key to long-term sustainability is right there in how nature works. It uses renewable energy. Our way, relying on stuff that runs out, is by its very definition unsustainable. It's as simple as that. So that leaves us with one final massive question. The blueprint for a sustainable world is right in front of us. Nature has been testing it for literally billions of years, and we know it works. The principles are clear. The only question left is, what are we going to do about it? How are we going to choose to build our future?